Today we're going to talk about systems of equations and solving them using elimination and substitution, two algebraic methods. The first thing we're going to talk about is substitution. When we're doing substitution, the first thing you want to do is look at one of your equations and solve for one of your variables. It doesn't matter which equation you pick, but usually one is easier than the other. And it doesn't matter which variable you solve for, but again, sometimes one is easier than the other. Then once you have it solved for that variable, you're going to substitute that equation into the other equation based on the variable that you solved for. And then we're going to plug in any value to any equation to find the other variable once we've solved for that first one. So, in example number 1, negative 2x plus y equals 8, and 3x plus 2y equals 9. Those are our two equations in this system. That top equation already has y that doesn't have a coefficient. So that's going to be the easiest variable to solve for, because every other variable has a coefficient. So here we're going to start by solving for y in the first equation. Y equals 2x plus 8, or 8 plus 2x. This time it doesn't matter. So now we're going to take that equation for y and plug that into the y of the other equation. So wherever I see y on that bottom equation, I'm going to put 2x plus 8. So now we have 3x plus 2 times our value of y was 2x plus 8 equal to 9. So now notice here we don't have any y's in this equation, we only have x's, which is what we want. Because now we're going to solve for x. We're going to figure out what that number actually is. So let's simplify. First we're going to distribute the 2. So we have 3x plus 4x plus 16 equals 9. I'm going to do two things at once. I'm going to combine the 3x and the 4x, and I'm going to subtract the 16. So 3x plus 4x is 7x, and if I subtract 16 from both sides, I get negative 7 on the right. And now we can divide by 7, so our value of x is negative 1. So this x here is part of the solution of these two equations. We should get a point at the end, right? 2, 4, or something like that. X is that x value. So now we just need to figure out the y value, and in order to do that, we're going to plug this x value back into either equation, does not matter which one, and figure out what the y value is. I'm going to use the top one for no reason, just because I can. We can use the original form or the form that we had changed around. Again, doesn't matter. I'm going to use the form we changed around because y is already by itself. So then y equals 2 times negative 1, which we just found, plus 8, which is negative 2 plus 8, giving us 6. That's our value of y. That means the solution to this system, the place where these two lines are going to intersect, is at the point negative 1, 6. And if you want to graph these two equations, just to check, you can do that, but you can also do it algebraically. Let's look at another substitution example. 4x plus 6y equals 18, and x equals 2y plus 8. This one's nice because x is already by itself solved for, so we can go straight into substituting that into our first equation. So when we do that, we've got 4 times our value of x, which was 2y plus 8, plus 6y equals 18. I just put this equation in for x, and now we simplify. Distributing the 4, 8y plus 32 plus 6y equals 18. 8y plus 6y is 14y. And then 18 minus 32 is negative 14. Dividing by 14, y is equal to negative 1. So we found the y value of the intersection. Now we just need the x value. Using either equation, doesn't matter which one, we can find x. I'm going to use the second one. So x is equal to 2 times the y value that we just got, plus 8, which is negative 2 plus 8, which is 6. So that means that the intersection of these two lines is at 6, negative 1. Let's do some more examples of solving by substitution. Number 3, we've already got y by itself in that top equation, so I'm going to substitute that in for y in the other equation. That means we have negative x plus x minus 4. You can put this in parentheses if you want, or not. Since we're adding it, it won't make a difference. Equal to 3. Combining like terms, we have negative x plus x, which is 0x, minus 4 equals 3, but this is not a true statement. So that means since this does not come out to be a true statement, there is no solution to this system. Number 4, the second equation already has y solved for. So then we can substitute that y into the first equation. So we've got 4x plus 2 times negative 2x plus 5 equal to 10. When we simplify, first we're going to distribute. So we have 4x minus 4x plus 10 equals 10. Notice that 4x minus 4x is 0, so we have 10 equal to 10. If we get the exact same number on both sides, if this is a true statement and there are no variables, then we have infinite solutions. I, as for infinite solutions, meaning our lines are parallel.